So today we're going to add our final exponent rule, which is our division properties. So we're going to simplify exponential expressions involving division. And if we look at the board here again, we can see, x to the 6th over x to the 3rd. There are the 6 factors of x in the numerator. There are the 3 in the denominator. And remember that anything over itself would be a factor of 1. So this would be 1 times 1 times 1, and then we'd have 3 factors of x in the numerator. So we would end up with x to the 3rd. Now, where does that 3 come from? Take the 6, the top numerator, minus the bottom, and there comes the x to the 3rd. So that is really our basic rule today. And let me just show you again. If I take those 7 factors of m and put them on the numerator, and those 5 factors of m and put them in the denominator, and basically I can cancel and cancel and cancel and cancel and cancel, because m over m would be 1. So we'd have 1 times 1 times 1 times 1 times 1 times m squared. So the other way that we can look at that is we could bring this guy up. Do you remember the negative exponent rule? And we could bring him up and put him in the other place and make him negative. And then if we have a common base and we multiply, we add the exponents. So there's several different ways to get to the idea of this, but basically, when you are dividing, you take the top exponent minus the bottom, and that will give you the exponent of your answer. And you're going to hear me talking a little bit about a Woodruffism as we go through here in a minute. And so if we take a number here, it's kind of that same idea that we did in the last video, that if we're raising a quotient, a division, to a power, we can kind of distribute that exponent to the numerator and the denominator. And that would be like 1 to the 3rd over 2 to the 3rd, which would be 1/8. Or the other way to look at it is if we took those factors of 1/2, there's 3 of them. 1 times 1 times 1 would be 1, and 2 times 2 would be 4 times 2 would be 8. But it's like a 1 to the 3rd over 2 to the 3rd, which would be 1 to the 8th. So that's basically our 2 rules. So our quotient, which again is division. So when you divide powers that have the same base, you write the base, and it's the top exponent minus the bottom. The order matters in division. Also realize that your base can't be 0 because you can't divide by 0. So if we take a look at this one right here, 4 to the 8th divided by 4 to the 3rd, write your base and take the top exponent minus the bottom, and 8 minus 3 would give you 4 to the 5th. I'm going to tell you the number one mistake here would say, oh, 4 divided by 4 is 1. It's 1 to the 5th. No, no, no. When you're dividing, you write the common base, top exponent minus the bottom. So if we take a look at this one, see, in my mind, like working with this negative, right, you would take the top common base, write the base, top exponent minus the bottom exponent. And 3 minus a negative 4 is the same thing as 3 plus 4, which would be 3 to the 7th. But this guy, we could also think about our negative rule would come up. Like, think about him reciprocating because he's a negative exponent and coming up to join the 3 to the 3rd times 3 to the 4th. And then we could write the common base and add the exponent. So there are kind of multiple ways we can get to that 3 to the 7th. What works for you? Now, the second part of this was the idea that what if we have a quotient, a division, raised to a power? Again, remember that our denominator cannot be 0. You can't divide by 0. It's undefined in math. This is kind of the idea in my mind where you distribute, so the numerator gets the m exponent, and so does the denominator, the b. So you get a to the m times b to the m. Where is this used? Well, let's say we had something that looks like this. The 3 is going to get the exponent of 3. In the denominator, the x is also going to get that exponent of 3. 3 to the 3rd is 27 over x to the 3rd. And that's the simplification of this one. Okay, so let's see it in play here. So kind of in my mind, when I see this mess, I like to clean up what's inside first. So instead of just starting to go, oh, 2 to the 4th and 3 to the 12th, instead, can you clean this up before you make it more complicated? So the 2 over 3 can't be simplified any further, but x to the 3rd over x to the 1st would become x to the 3 minus 1 would be x to the 2nd. Now here comes the Woodruffism. If your exponents on the same base are positive, so this would be a 3 and this is a 1, look at it and ask yourself, where are there more factors of x? Are they on the top or on the bottom? And here you would say, well, there's more x factors on the top. There's 3 here and 1 there. And then I would ask you the question, how many more? And you'd say, well, x to the 2nd. So that would tell you to put x to the 2nd in the numerator. Now, when we come out to the y's, now they're both positive, 4 up here and a 1 down there. So once they're both positive, where are there more y's? On the top. How many more? Well, 4 minus 1, 3. So that y to the 3rd would be on the top in the numerator. So do you see how the inside, using our division or our quotient rule, becomes this? Now we've got to take our last video and raise everybody in here to the 4th. So 2 to the 4th, x to the 2nd to the 4th, y to the 3rd to the 4th, and on the bottom, 3 to the 4th. 2 to the 4th is 16. Then we would have x to the 8th and y to the 12th. And on the bottom, we would have 3 to the 4th, which is 81. And we are done cleaning that up. So let's do some more of these. And what you have to understand is everything is in play now, all 5 rules. Now, I want to show you this one, and I'm going to talk it through 2 different ways. So we could use our quotient rule and say we have a common base. So we would take 8 minus 4, and we'd have m to the 4th. And we could take 3 minus 5 and have negative 2, and then we would have to move that n to the negative 2, reciprocate it to the other place, and make it n squared. And we'd end up with this answer. The other way that I look at it is, without even going, this is kind of what I just mentioned, I should have said that. I look at it right here and I say, okay, look at the m. See how they both have a positive exponent? Where are there more factors of them? In the numerator. How many more? M to the 4th. So there should be an m to the 4th in the numerator. Now look at this. Are they both positive exponents? Yes, they are. Where are there more n's? In the denominator. How many more? 2. So there would be an n squared. I would actually go from this directly to this by using that kind of Woodruffism idea. You can use the quotient rule and get there as well. Okay, let's take a look as things get more complicated here. The first thing I notice is we have an exponent, nothing to clean up inside. So I'm going to start by raising everybody in the parentheses to that 3. Can you do that, please? And did you get 3 to the 3rd, which is 27, y to the 3rd, and x to the 6th? Now you might say, where is this? Just hang on a minute, okay? So cover over this x to the 1st, and that's what you should have. Now when I look at the denominator, the 9 is still going to be there, but this guy is going to reciprocate and come to the top. That guy is positive, he's going to stay on the bottom. Let's make sure that you understand. 3 to the 3rd, y to the 3rd, x to the 2nd to the 3rd. The x to the negative 1 reciprocated and became x to the 1 on the top. 9 is on the bottom, stays on the bottom. He's 9 to the 1st, he stays there. Y to the 2nd stays there. And now we need to clean it up further. Can we clean up the numbers? Can we clean up the y's? Can you try to do this one yourself? 27 divided by 9 cleans up quite nicely. I have 3 y's on the top, 2 on the bottom. They're positive exponents. There's 1 more on the top. So the y to the 1st would be on the top. Oh, by the way, y. And when I'm multiplying common bases, I add the exponents. So I'd have 3 y x to the 7th. And that, wow, what a mess. And look how nicely it cleans up. All right, let's talk about a scientific notation. So when you're dividing really big numbers or really small numbers using scientific notation, it's easier to leave them in scientific notation and do our exponent properties. So here, you would take 2 divided by 8. So you're still going to do the division out here. And if you take 2 divided by 8, you should see 1/4, which is 0.25 x. There's the x. So here is the case where I will use that 3 minus 8 to give me 10 to the -5th, because remember, we can have negative exponents in scientific notation. This is going to be a really small number. So I divide the numbers in front, top divided by the bottom. That gives me the front of the scientific notation. There's our x, and now I'm going to use my new division rule. I'm going to write my common base and top exponent minus the bottom. So here I go, except stop. Why is there another box? This is not in proper scientific notation. So you're going to wrap that decimal around and have 2.5. You just made it bigger. You just kind of put in a power of 10. You need to take 1 away. Be careful with the negative. You need 1 less than -5, which would be -6. And that's how we divide scientific notation. So I have a huge mess. Are you ready? What we are going to do right now is we are going to clean up this whole product up here. And you're going to notice some errors. So what I'm going to do is I'm going to ignore him. See, I'm going to write him down here, and I will deal with him in a minute. I'm going to start by simply trying to clean this up using my 5 exponent rules. So don't pay attention to him for a second. The first thing I'm going to do is I like to get rid of all the negative exponents. So I'm going to reciprocate the x to the -3 to the other place and make it positive, and the same thing with the y. So let me show you that. Does everybody understand what I just did? Now, oh, look, multiply. When I multiply common bases, I add the exponents, and when I multiply common bases, I add the exponents. 5y to the 3rd over x to the 8th. And now that's as clean as this expression is going to get, so let them sit there for a minute, and we'll bring them back in a minute. Now I'm going to look at this guy. The first thing I notice is there's an exponent. So I'm going to raise, actually, I take it back. I'm going to move this whole thing to make it a positive down to the denominator. So I'm going to take this whole group, put them in the bottom to the +2, and I've left a 1 on the top. Now when I square the 2, I get 4. X to the 2nd, y to the 6th. Remember, this is now a +2 in the denominator, and there's the x, y still hanging out. The parentheses are no longer necessary. So I have 4, x to the 2nd times x to the 1st, add your exponents and get x to the 3rd, and y to the 6th times y to the 1st, add them. And I have now cleaned up the second one. So this whole mess is 5y to the 3rd over x to the 8th, and this whole mess is 1 over 4 x to the 3rd y to the 7th. If you need to pause the video to just look at that, please do. Otherwise, we're going to move on because we still have to multiply these two together. And that's what's behind this box. So I brought these down, and now I need to clean this up. So I see 5 over 4. Everybody okay with that? I have x to the 8th on the bottom times x to the 3rd. I'm going to multiply common bases and add the exponent and get x to the 11th. Now look at your y. So I've taken care of the 5 and the 4. I've taken care of the x's. I'm now looking at the y's. My y's both have a positive exponent. So I'm now going to look at the fact that there are more on the bottom. How many more y's are in the denominator? And you will see 4, so that we will land with a y with 4 in the bottom. Oh, by the way, 3 minus 7 is -4, but then we would have had to move it to the bottom, reciprocate it, and make it y to the 4th. This whole gigantic mess simplifies quite nicely to that. So where we are is we are using all of our rules. So we have a 0, Negative exponent, we have multiplication, powers to a power, and division or quotient. And so now it's not just about the division rule today, it's about mixing them all up. I have to admit, I actually love doing this. It's like cleaning up the house. I don't like cleaning my house, but this feels like I'm cleaning my house and tightening everything up. And I actually enjoy doing this. So you can have a little fun with it. Don't let it bog you down. So we're going to be practicing more. And really, it's all about getting these 5 rules all mixed up, including our scientific notation, and using those to simplify expressions. Have a great day, everybody. I'll see you soon.